Let's say we continue with integrating the chains of functions. Chains of functions. So we do the same thing. Now, if let's say you have product of two functions, we always inspect in this way. Which function that we, maybe between the two product of the two functions, which one we might have derivated and get the other? Did we derivate x to get something inside the root? No. But we can get derivate what is inside the root and get what is outside. And I hope you see that we see that derivative of x squared plus 1, it is 2x. There's a factor which is missing there, or derivative which is 2. So we'll have to divide by that factor if we're using inspection. But if let's say you wanted to utilize, let me express it in that rule, the power bracket rule. So we're not changing that into exponential form. What do we have? We have x squared plus 1, all in all to the power of half. So you can utilize the u-substitution method. So we can say we want to let what can give us the derivative of the function outside there to be equals to u, or x squared plus 1 equals to u. Then from there we can change the function in terms of x. So if we derivate the right and left hand side in terms of x, we're going to have 2x equals to u over dx. So normally when we derivate here, we say that multiply this by dx and the other side and say du to simplify a problem. But we are still in the beginning stage. You will see why we say that. So in the meantime, we're going to make dx subject of the formula. So if you make the x subject of the formula, you're going to have du all divided by 2x. So we have divided on both sides by 2x and multiply on both sides by dx. We have multiply on both sides by dx and divided by 2x on both sides. I hope it's clear. So in the meantime, now we're going to have now function. It is equals to now to try to integrate. So we're going to have x squared, x to say. So we said x squared plus 1, it is equals to u. And all in all to the power of half, 1 over 2. So it's 1 over 2. Then divided by, no, this is not divided by, multiplied by dx. So what is dx? Dx is equals to u over 2x. So from there, we need to simplify. We cannot integrate while we have variable x and variable u. So we must have at least now dealing with one function because we're converting x to u now. So, but in the meantime, we know at least here we can divide x by x. I hope you see that. So therefore, we're left with 1 u to the power of 1 over 2 times du. As we said, we divided x by x because this in the denominator is dividing the numerator. And we're left with 1 over 2. So as I'm saying, I'll be factoring out 1. And in the denominator, I'll be factoring out 2. So we're left with 1 over 2 as a factor. Therefore, now we can focus on the function u and integrate in terms of u. So we know that is a power rule. We're going to add 1 into half. Add 1. Half plus 1 is 3 over 2. So as I said yesterday, you said that is a double division. Please note that if you say 3 over 2 divided u divided by 3 over 2, it will go to the numerator and we'll have that. So divide 1 by 3 over 2, we have 2 over 3. I hope you recall from yesterday. So therefore plus C. So it's a double division. So 1 divided by 3 over 2 give us 2 over 3. Therefore, it will be equals to Please substitute back the functions that you said, the value of u to say, the function that you said is equals to u. So we said it is x squared plus 1, all in all to the power of 3 over 2. Therefore, plus the constant. If you want, you can leave your answers in set form. In set form. You can leave it in set form and say square root of x squared plus 1, all in all to the power of 3. That's how we do the integration. But using inspection method from the initial step, as long as you saw you have a derivative, where is our half? I lost our half. I lost our half. This is multiplied by 1 hour half there because here we added 1 and we divided by 2 over 3. So hence our answer, if we have 1, 2 over 6, it's going to be 1 over, it's going to be 1 over 3. So we missed that factor. Okay, that's number 3. So let's say maybe we look into integral of cot 2x, all divided by ln of sine 2x. So now I want us to look into quotient, where we have to apply natural logarithm. So we pass through the products where we have, let's say, chains of functions. So let's look into this one, where we have quotient of functions. Inspection have to work here. So, with explanation of the previous lesson, so we stated that you inspect numerator and denominator. So what do? You inspect the denominator. If when you derivate the denominator, are you going to get the numerator? That's how you do it. To inspect the denominator, if when you derivate, it's going to give you the numerator. By inspection, you can say yes, because derivative, let's say, of the denominator, it was going to be 1 over sine 2x multiplied by cos 2x. So cos over sine was going to be cot, which is true. The only thing which is missing is factor 2. So which means I will need to divide by factor 2. So this now calls to this formula by inspection, as we mentioned in the previous exercises, dx. That if we inspect that the denominator, it gives us the numerator as a derivative. So we know that therefore integral of that is equals to, we'll say ln of the denominator. If there was a factor missing, we're going to say divide by that factor that we are missing. Hope it's clear. So, but now let's try and utilize that new method. But I want you to know inspection method. You need to know how to inspect functions. What did you derive to get this? Or which rule was applied? So what did we derive to get this function in terms of x? We have derivated this function to get that. So, but let us utilize, as much as I've inspected, I'll let the denominator to be equals to u. So let u to be equals to ln sine 2x. So it's ln or natural logarithm of sine 2x. Now let's derivate in terms of x. So we derivate u in terms of x, it will be what? du over dx is equals to that. And therefore derivative of ln sine 2x. So it's 1 over sine 2x. And then numerator multiplied by derivative of sine, which is going to be 2 cos 2x multiplied by derivative of the angle, which is 2. Therefore, multiplied by dx. I said the more we advance, we'll be no longer writing over dx, we just multiply by dx on the right hand side. Therefore, if let's say you're still simplifying, as we know we want to make dx subject of the formula. In the meantime, let us simplify this. We're going to have 2 cot 2x, because cos over sine, it is cot. Therefore, multiply by dx. Let us make dx subject of the formula. So if dx, to make it subject of the formula, we divide on both sides. It functions. So we're going to have du, which now is divided by 2 cot 2x. So we have 2 cot 2x. So as I said, the factor that was missing initially when I was inspecting there, I saw it was 2. I was going to divide by 2. So u method, at least you go with the missing factors and replacing x and tx in terms of u. So in our given derivative, we need to determine the function now. It's going to be equals to. So when we substitute cot 2x, didn't replace, but we have replaced ln sine 2x as n equals to u. Therefore, we said dx. Please don't forget about dx. dx is equals to du over 2 cot 2x. That is u. That is dx. So simplifying further. So when you simplify further, then every time let me insert it here. I hope you see that cot 2x will divide cot 2x, isn't it? So cot 2x is divided by cot 2x. Please, as I spoke about the factors, if you don't want to factor it out, please, it's fine, work with it, but just want to factor out the constant there, 1 over 2. And we'll be left with 1 over u to du. So left with 1 over 2 in integral of 1 over u du. So I know you could want to think of power rule, isn't it? But we said power rule is applicable when n is not equals to -1, isn't it? So which means that we know that this came from the derivative of ln of the denominator, ln u. Therefore, plus c. So when we derivate this in terms of u, we're going to get 1 over u times 1. So please pay attention. If let's say your function there now, its exponent, when you take it to the numerator, it will be -1. Please know that power rule is not applicable. That was derived from a natural logarithm. I hope you still recall from the previous lesson. So therefore, we can substitute back the function that was in terms, which was replaced in terms of u. So we'll have 1 over 2 ln. Therefore, u is equals to ln is equals to ln sine 2x. So it's short, therefore plus c. Then we're done. That is our solution. So I hope you recall here when I said if this gave us the numerator, I was supposed to have ln of the denominator divided by the constant there, which was missing, 1 over 2, therefore plus c. Okay, I hope it makes sense now. So we're looking by inspection. We know always exponential functions, when you derivate, it will always appear as it is. It will always appear as it is. So what we're going to do, we know that if we have derivated this by inspection, we know that derivative of root cos x, it gave us a negative something, was change of functions. So it gave us a negative half, and derivative of x cos x, we know it's sine x. That's the only thing which is missing. I hope you see. It's a half and a negative, because derivative of cos is negative sine. So we're missing a negative sign x, negative to say, and a half, because derivative of the square root, it is half, then we're supposed to subtract 1. Hey, today, you didn't pray, no? Or maybe there's some problem, that's why. Once you go, check, I must go fast. Disappear. So, but what we'll always advise you is to take the whole exponent and let it equals to u. So we normally take what is in the exponent to be equals to u. So we say we let now root cos x, we say, to be equals to u. So in that case, we can derive in terms of in terms of x. But if you want, you can even take what is inside the exponent. It's fine. But if you take the whole exponent, it helps you out so that you don't lose the factors. If you take cos x, or when you say log, no, you can't do that. Why? It won't integrate the function back to where it came from. This we know that was a derivative of the exponent. So hence, we take the whole function. Exponential function is the one which can produce the vectors that you see here. In fact, for that question, so please don't just take anything to be equals to you. So which one might have you when you have derivated to give you the certain functions that you're having? So we know that these functions came from the derivative of the exponential function. So hence, when we let you, we're going to let what is inside the exponential, not inside, on as the whole exponent. So when you simplify this, I hope you see you'll be having, before you even derivate, you'll have cos x falling onto the power of half equals to u. Then from there, we can now derivate the function in terms of x. So derivative of this, I hope you see it's a chain of function where we're going to have 1 over 2 inside the bracket. We still have cos x all in all to the power of what? Negative half. So we subtract half. So we multiply by the exponent and subtract 1 from the exponent. We need to multiply by the derivative of what is inside. So derivative there is negative what? Negative sine x. We're supposed even to multiply by maybe the angle, the derivative is 1. So on the other side, derivative of, we said please multiply by dx, and therefore and say it equals to the derivative of u, which is du over dx. So we just multiply it out on the right hand side because we know at the end we need to multiply out by dx. From there we need to simplify. Simplifying fully. So you have to pay attention. You see that the exponent is negative here. We have to take it down. And again, if it's going to be positive half, now it's going to be what? Root x cos x, isn't it? So they have root cos x. So we're taking the exponent, we're taking base cos x to the denominator, it became positive half, and change it to root form. So we have root cos x. So it means with 2 there in the denominator. Number 2, as this is still multiplied by dx, so it's equals to du. So we want to make dx subject of the formula. So what do we do? So dx subject of the formula is going to be equals to, in the summary, we multiply by 2 on both sides of the function, right? Multiply by 2 here, it is eliminated. On the right hand side, you'll have 2. We multiply by cos x here, if cos x will divide here. On the right hand side, it is multiply root cos x. So to get rid of negative sign x, it's multiplying here, we do what? We divide. So you say sin x divided by sin x. Out on the right hand side is divided. So we have negative sin x. Therefore multiplied by du. So that's what we did. So we divided on both sides by sin x over 2 root x. Because as I said, divide on both sides by sin x. We divide here, it's eliminated. On the other side is divided. What we did, we multiplied on both sides of the function by d root 2 root x. Here it multiplies, it's eliminated. Here it's multiplied on du. I hope it's clear. Therefore, now we can now replace our root cos x by u, or replace dx by this whole expression here. So therefore, our solution will be equals to. So we said that root x is equals to u. Therefore, here we still have sin x all divided by x cos x. So dx. So dx we said is equals to. So I hope we see that dx is 2 root cos x all divided by negative sin x multiplied by du. So dx will substitute value of dx, which is root 2 root x over negative sin x. Now we know that with the u method it help us to simplify in a way of dividing most of the functions which were there. We want to get rid of the x and be left with u. So we see that root cos x, it's divided by root cos x. Sin x is divided by sin x. I hope you see we're left with factor negative 2. I hope you see that. Okay. So from there we can factor out that negative 2 and focus on the function which is in terms of u, as we have divided sin x, and sin x is root cos x with root cos x. We're left with e to the power of u times du. So this is easy as basic. So we know that when we integrate an exponential function, it always comes back as exponential as it is. And we're supposed to divide by ln of the base, ln e. Ln e is 1, and derivative of the exponent, which is 1 in terms of u. Therefore, plus a constant. So e to the power of x is still e to the power of x when you integrate. So here is in terms of u, we work in terms of u. So therefore, the answer is going to be equals to negative 2 e to the power of root cos x, therefore plus c. So this is what we derivated to have this function. And when you want, you can try and prove it when you're done. So you can derivate the exponential function, it will be e to the power of root x multiplied by the derivative of the exponent, which is going to be half root cos x in the denominator times negative sin x. And then the half will get rid of the half, and the negative get rid of the negative. We still have that expression there. Okay, I hope it's clear up until so far.